Okay, good morning. This is Professor David J. DelosReyes. Okay, for this morning, my topic will be the continuation of alternating current circuit. Before I will finish alternating current circuit to discuss a new topic, I want to end this alternating current circuit with this lesson number 39. Okay, lesson number 39 is the title is Single Phase and Three Phase Connections for Loads okay, in Real Life. Okay, let's proceed. The subject matter for this morning will be Alternating Current Circuit, lesson number 39. And the title of the topic is Single Phase and Three Phase Connections of Loads under Alternating Current Circuits in Real Life. Okay, let's try to bring out a figure. Okay, this will be the big figure. I will be drawing three lines here. So the first one will be line number 1, line number 2, and line number 3. And these three lines are actually the transformer secondary. Transformer secondary, the so-called distribution transformer, which is hung on the post outside, right? Like this one here, the last portion here. We got a post over here, and the one that's hanging over here is actually a distribution transformer. Okay, and this distribution transformer is actually a three-phase. We got three lines over there, three lines. So those three lines there are actually line number 1, line number 2, and line number 3. This is line number 1, line number 2, and line number 3. So to distinguish a single phase from a three-phase load, okay, for the single phase load. Single phase meaning the load is only using two lines, okay? So if you are considered to be a single phase load, okay, your service entrance, the lines going to your house will just be simply line number 1 and line number 2, plus the ground circuit being given by the utility company. Okay, so if we are considered to be a single phase load, considered C sub L, this might be a household. Okay, designated by C sub L. And if you are to be considered a single phase load, you are only connected to either line number 1 and line number 2. Okay? For a three-phase load maybe, this is now a three-phase load. It could be a corporation maybe. Big corporation. Like Amazon maybe, one location of an Amazon, right? The load for Amazon, there are lots, right? So instead of just using a single phase load, Amazon will be connected as a three-phase load to the transformer. So the load of Amazon will be segregated into three things, right? Segregated into three things, meaning there should be C sub 1, there should be C sub 2, and there should be C sub 3. And these three loads here should be balanced. Should be balanced. So if this is 200, assuming 20 kVA, the other one should also be 20 kVA, if possible. And the third one should also be 20 kVA. The main reason behind for it to be balanced is that to avoid the so-called circulating current in the system. Because if the load is not balanced, there will be a circulating current, and that circulating current wastes energy. So for design engineers, they make it a point that the load balance, or the load in its space will be balanced. 20 kVA, 20 kVA, 20 kVA. Meaning to say, load number 1, if Amazon is to be considered a three-phase load, is connected between line number 1 and number 2. And load number 2, it's still the load for Amazon. It is connected for load number or line number 2 in line number 3. And the third load, which is still a part of the load of Amazon, okay, is connected between line number 1 and number 3. And that is to be considered a three-phase load. So for ordinary household, we are classified as single-phase loads. We are only connected to line number 1 and line number 2. Okay, that's the difference between a single-phase load and a three-phase load. Okay, so these three lines here are actually the output lines of a transformer. It is something like this, right? Then this one here, it is something like that. So this portion here is a transformer. Okay, which is hung on the post going to our houses. So there will be three lines over there. So if the transformer is three-phase, there should be three lines coming out, right? This one here. Because if the transformer is just single-phase, it could not serve a three-phase load. There should be three lines to serve the three-phase load, right? So the circuit diagram of the transformer will be something like this. So for a three-phase load, we need three lines, okay, to connect a three-phase load. Between line number 1 and number 2, that will be one load. Between line number 2 and number 3, that will be another load, second load. And between line number 1 and number 3, that will be a third load. So these three loads should be balanced, and it is considered to be a three-phase load. So if we try to view the so-called, I will try to erase this one. If we try to view the so-called electrical grid of an electrical system, it will be something like this. These are transmission towers. Okay, this is just like a diagram for a substation for stepping down the voltage from 133 kV to 13.5 kV. And going to the secondary of the substation will be still a post, but it's different from the transmission tower. This is now a wooden post, but it's very high, around 30 feet maybe or 40 feet. And there are actually posts which is smaller than 40 feet that is going to our houses, maybe 25 feet to 30 feet, and this will be this one. Okay, so the electrical grid will be something like this. This came from the power plant, and from the power plant it goes to our houses, right? So to deliver the power from the power plant going to the clients or houses, you need a transmission line, a high voltage transmission line. Maybe the voltage is 133,000 volts. And upon reaching a certain point along the line, this 133 kV will be stepped down to a voltage of around 13,500 kilovolts. Okay, or 13,500 volts. And from the secondary of the substation, okay, it will go to another post which is around 40 feet. Okay? It is considered still a primary line, and which the voltage hanging over there will be a step-down transformer that will convert that 13.5 to around 5,000 kV. 5,000 kV. Then this is connected still to the secondary lines. This portion here are secondary lines going to the small post. Okay, and on the small post, there should be again a distribution transformer, okay, which will convert that 5,000 to a usable 120 volts. 120. Okay? For us to be safe, they will change this 5,000 volts to 120 so we could use it to our houses. So actually the output of the transformers and the secondary phase are actually rated maybe 5 kV primary, and the secondary will be 120. But for a three-phase load, it depends. If the voltage requirement of a three-phase load is not 120, okay, utility companies could actually designate a transformer exclusively for them. That's why big corporations got exclusive transformers in which their voltage rating is actually uh, in relation to the voltage needed by their three-phase load. But for ordinary households, the secondary of the transformer is actually 120 volts. That's why here in the USA, the voltage going to our houses are actually 120 volts. Okay, that's it, guys. This is the electrical grid. This is a complicated thing, right? High voltage transmission line, 133,000 volts. It will be stepped down to a 13,500 volts. And this 13,500 volts run to the primary lines, okay, and which will have a transformer again that will convert this 13,500 to around 5 kV. Then this 5 kV is fed to the so-called secondary lines, and at the end of the phase of the secondary lines are actually distribution transformers. Again, it will be stepped down from 5 kV to 120 for households, okay? But for big corporations, it depends on their voltage needed. If they needed a 5,000 volts, okay, you don't have to step down this one, right? If they needed a 580 volts, okay, the transformer here should be 5 kV slash the secondary should be 580. It depends, okay? That's how we get our power from the utility line. This is still under alternating current circuit. The source of the power are actually, there are lots. Hydro for water, okay, solar, okay, what do you call this, nuclear, it depends. Here in the USA, there is the nuclear and there is even the wind turbines, right? All voltage sources are going to the transmission lines. Because to deliver power to the households, okay, we need transmission lines, substations, primary lines, secondary lines, and distribution transformers. Okay, that's it, guys. I think this will now be the end of my topic under alternating current circuit. At least we now know the preview on how we get our power from the utility companies. It came from the power plants. It goes to the high voltage transmission lines. It goes to the so-called substations. These substations go to the primary lines. And these primary lines, there are step-down transformers which will feed the secondary lines. And these secondary lines, there are again distribution transformers which will step down that 5 kV to 120 volts for house customers. Okay, that's it, guys. I think this will be the end of my alternating current circuit topic. So for those of you who are taking up electrical engineering, this is for you guys. If you want to subscribe to my channel is at youtube.com/@ProfDavidJDelosReyes. If you want to share it, please click share. I hope you got something that I've learned from my topics under alternating current circuit. Okay, good morning from Los Angeles, Professor David J. De Los Reyes.